Hello everyone and welcome to this Green Building Pro online event series broadcast, Localizing Architecture, New Thinking and Sustainable Materials. The Green Building Pro online event series features regular multi-hour events focused on a specific topic within the green building and sustainable design industries. The entire event series will be hosted here in the Green Building Live Events Center. This webcast is brought to you by CMC Media. I'm Mitchell Funk, Editorial Assistant for Green Building Pro, and I'll be your moderator today for this webcast. In a few moments, Kevin O'Donnell will join us to discuss the newest green materials released and also suggest strategies for finding leading-edge, sustainable material manufacturers. First, I want to go over a few housekeeping details before we begin. The webcast today is intended to be interactive, and we may prompt you with polls from time to time. You also have the ability to ask a question at any time by using the Ask a Question chat box at the bottom of your screen. You'll notice the little send button there. It's a live public chat. We'll address all your questions during a Q&A session later on in the program, but again, do feel free to submit them at any time. During the presentation, if you ever need to get a closer look at any slide, you may use the Expand Slide button at the bottom right corner of the video screen. Looks like a little monitor there. We want you to follow along with the presentation today and share your attendance with the community. You'll find a rolling Twitter feed on the right-hand side of your screen there. Remember to use the GBExpo hashtag when you describe your attendance today so others may join in. And be sure to stick around to the end of this presentation. We'll be giving out 5 copies of Ross Spiegel and Drew Meadows' book, Green Building Materials, at the closing of this webcast. We'll provide some more details on that right after Kevin's presentation. And with that, I want to introduce our speaker today. Joining us is Kevin O'Donnell. Kevin has worked in the retail industry for more than 20 years, championing cutting-edge design, carefully integrated architecture and store decor, creative brand development, insightful business strategy, inventive conceptual approaches, and innovative use of materials and production methods via key projects for Tesco's Fresh and Easy, Whole Foods, Kroger, and Wegmans. Kevin founded the LA design and consulting studio Thread Collaborative. His team researches, develops, designs, and writes about innovative strategies to achieve sustainable building development. He educates and lectures from local, regional, and national platforms, including UCLA Extension, SCI Arc, the Bartlett, FMI, AIA, ASID, IRDC, and NeoCon events. With that, I want to thank you, Kevin, for joining us today. We look forward to a really great show.
Thank you for that introduction. Thank you, Mitchell, and thank you to Green Building Pro. Good morning to everyone who is on the U.S. West Coast, and I guess good day to everyone else. I'm going to be doing a presentation this morning called Localizing Architecture. I hope you find it interesting. We've got a lot of material to cover, so I'm going to start plowing through it. So, one of the things I found as an architect, I've been an architect for about 15 years now, focusing primarily on retail design, retail branded retail environments for clients like Whole Foods, Walmart, done things with Coca-Cola, Wegmans, all sorts of different retail clients. But about 6 years ago, I started getting questions. And at the time, sort of looking back on it in hindsight, they don't seem like they're that complicated a set of questions, simple things about the various products that I was specifying for different projects. But at the time, I really had no answers for any of these kinds of questions. How can a product be reused? Is it biodegradable? What happens to it at the end of its life? I really had no answers to any of these questions, and my clients were starting to press me pretty hard on getting them answers. The one that I want to focus on today actually is the last one, which is where does it come from? And in fact, that's a very interesting question because I had all sorts of assumptions about where things came from. So if I looked at a map of the United States, I automatically assumed that most wood products come from the Pacific Northwest, steel comes from the Northeast in Ohio, Pennsylvania, New York, brick comes from the Mid-Atlantic, Tennessee, North Carolina, South Carolina, areas like that. And textiles of carpet and tile and other things come from the Southeast, especially like Georgia, Alabama, Mississippi. But what I found in trying to answer the questions for my clients is that I really didn't know any of those answers. And in fact, the one that really stumped me was where things come from. That my assumptions about where things come from was totally wrong. And that even a domestic company, or a company that's headquartered domestically, some of their raw material, or even if they assemble the final product domestically, that oftentimes the raw material where it's extracted from the point at which it's extracted from the surface of the earth could be thousands of miles away. And in fact, that's what I found about most building materials. In addition, I found all sorts of information the more research I did about things that were in those materials that were really a problem for a lot of my clients, and for my clients' clients, essentially their customers. Most of us are familiar today with the term volatile organic compounds, or VOCs. It's in virtually all coatings, paints, stains, solvents. Now, there's plenty of water-based ones that are now available on the market. Only within the last couple of years has moved towards no or low VOC become really popular, but still the vast majority of what you can find on the market today in terms of paints and stains and coatings and sealants and adhesives still has volatile organic compound, which is essentially that smell. It's a chemical that's added to the material. That's essentially a release agent that causes it to dry faster, and it's that new paint smell that you often get when you go into a room that's been freshly painted. It's a chemical, and it's studies have shown that it is a hormone disruptor. It actually has the ability to cause all sorts of different problems as it accumulates in the body. Another one to be concerned with that I found pretty shocking was formaldehyde. Now, formaldehyde is a natural material. Most of us are probably familiar with it with high school biology classes, and the fact that we probably had to dissect some frog or some animal that was stored in formaldehyde. It's essentially a natural preservative. And all wood at some level has some degree of formaldehyde in it. But what most wood manufacturers do is actually add formaldehyde because of its preservative qualities. They don't want the wood to rot, essentially to start decomposing. And so they actually add formaldehyde. Sorry about that, something happening on my screen. So they actually add formaldehyde to keep it from decomposing. Formaldehyde is what scientists call a persistent bioaccumulative, which means it constantly builds up in the body. The human body has no way to process it, and most wood products have been shown to off-gas that formaldehyde for as much as 5 years after the product is manufactured. Another material, PVC, is fairly common in buildings. When I did some research, what I actually found was rather shocking, which is polyvinyl chloride and other plastics within the building industry are only second to packaging. So the number one use for most plastics and vinyls is the packaging industry. The second most is the housing industry, or I'm sorry, the construction industry. And if you think about it, it's pretty much everywhere. Nylon carpet is essentially a polyester material, a petroleum-based polyester material. Vinyl flooring, vinyl siding, vinyl upholstery, vinyl coatings of all sorts, vinyl windows, trim, moldings, all sorts of different materials within the housing and construction industry are made out of PVC. Most of the textiles, and this is for our own safety, have been coated with flame retardants. One of the most popular is brominated flame retardants, or PBDEs, and they're in virtually all textiles that you find today. And what studies have found is that human contact actually can transmit those flame retardants into our bodies, and here too they can cause health hazards. Now, you would think that with the creation of the Environmental Protection Agency as a part of the Toxic Substances Control Act in the 1970s would have this under control, right? They'd be protecting consumer interests. Well, in fact, what has actually happened is that when it came into existence, more than 60,000 substances, chemicals, and other substances were grandfathered in. There was just no way to test the vast number of substances that were already on the market. So what they actually did is grandfathered in without any testing for long-term human exposure more than 62,000 substances. Since then, they've added 35,000 substances to their list. And in the last 35 years, they've actually only banned 5 materials: lead, PCBs, asbestos, DDT, CFCs. They're currently studying bisphenol A or BPA to see whether or not it will be added to this short list of products. The fact is that actually the EPA itself admits that probably more than 95% of all chemical compounds that exist in the market today have never been tested for long-term human exposure. And those that have been tested have already shown that there is some significant risk or some risk to human health as a result of exposure, and in particular long-term or heavy exposure to some of these substances. What I also found in my research in answering some of these questions for my clients is the amount of resources that are consumed by the building industry. Some estimates believe that nearly 13.6 of all potable water in the United States goes towards some form of either construction or in the production of construction materials, which is a pretty significant amount. One of the only things higher than that actually is agricultural use of water. And the building industry uses nearly 25% of all wood domestically. One of the things to keep in mind with resources is what economists call the substitution principle, which is that when a material comes on the market, typically its introduction is at a high price and low consumption, and that over time, as technology increases and if the material is desirable, the new technologies are developed in terms of harvesting or manufacturing or mining or other technologies to bring the price down. So price comes down as consumption goes up, and eventually hitting a peak supply and essentially its lowest point or lowest price point. And then on the back half of the curve, obviously the price comes back up as supply starts to diminish. But a natural condition occurs, a natural economic condition occurs, which is called the substitution principle, which is somewhere on the uptick, somewhere on the rise towards peak supply and lowest price and highest consumption. Substitutions are found, and new materials are used in replace of something that is starting to show limited supply. And then that curve repeats itself. Something to consider when we think about building materials all around the world and the amount of total resources that are being consumed by the building industry is whether or not this can go on forever, whether or not this cycle of substitution, one product for another, can continue forever. What's common in most industrial societies is a process that's quite linear. It essentially takes raw materials from the surface of the earth, manufactures them, brings them to market. We use them in the case of the construction industry or in architecture and design. We use them for the production of homes and buildings, commercial structures, residential, retail, religion, government, all sorts of different types of structures. Waste from that, not just from the manufacturing of that, but waste at the end of the life of the building and during construction. It's a linear process that is from cradle to grave, essentially transferring raw material of the earth into garbage. One of the visionaries out there talking about sustainable design and how industry needs to change is Ray Anderson, the founder and CEO of Interface Floor, one of the largest commercial carpet companies in the world. He did some research about 15 years ago when he started taking a look at the impact that his company was having on the industry. And what he found was to ship 1 truckload of finished carpet, his company generated 32 truckloads of waste. And that's from extraction of raw material to delivery of finished goods. His company is engaged in a process that produces 32 truckloads of waste for every 1 truckload of finished product. The conclusion he came to is that his company's not actually in the commercial carpet business. His company's in the business of converting the earth into garbage. If you take a look at all landfills around the United States, by volume, nearly 37% of all refuse is generated by building-related construction, either through manufacturing processes, through the construction itself, and end-of-life demolition. There is a considerable amount of waste that's generated in the construction of our buildings. One of the things that's really deceiving about most products is how little we know about them and the perceptions of whether or not they are local or whether or not they're something domestically produced. So let me just tell you a quick story about a simple product that we're all familiar with, the number 2 pencil. We've probably all gone through some period in our lives, either grade school or high school or even in college, when we've had to use a number 2 pencil for a test, some sort of standardized test. One of the most popular in the United States is the Ticonderoga number 2, which is produced by the Dixon Pencil Company out of upstate New York. And the assumption would be that, well, it's made by a U.S. manufacturer. It must be a domestic material. Well, let's break it down and take a look. So the number 2 pencil, fairly simple, right? It just has 5 components. The basic, most important piece is the graphite, the part that you actually write with, the wood sleeve. There's a painted coating on that wood sleeve. There's usually a brass device called a ferrule, which crimps the eraser to the back end of the pencil. Not always, but generally speaking, on most number 2 pencils, there's an eraser. So really simple, right? Just 5 simple components. How complicated could that really be? Well, if you break it down one step further, just take one step further and figure out, how is an eraser manufactured? How is that ferrule manufactured? How is that paint manufactured? How is that wood harvested and manufactured into the pencil sleeve? How is that graphite manufactured? Those 5 components end up leading to 42 different substances. Some pretty crazy things in there, right? Polyvinyl acetate, propylene, pumice, styrene, sulfur, an amazing collection of different substances, which all are used to produce that simple number 2 pencil. Now, if you take those 42 substances and start tracing where they actually come from, what you'll find is that the vast majority of them do not come from the United States. The wood is probably the only piece that comes from the United States. Some of that does come from the Pacific Northwest, but most of it comes from areas of Canada, depending on the wood species, and they do mix those up. But you can see by this map, most of the components come from all different parts of the world, from all 6 continents, and most of it ends up getting shipped to China, and that's where those pencils are manufactured. Those number 2 Ticonderoga pencils, manufactured by Dixon, are actually assembled in China and then shipped back to the United States, even though we consider that number 2 pencil, or think of it as a U.S. product. Very little or almost none of it's actually manufactured in the United States. One of the fastest growing food movements in the United States right now is the local farmers market. About 44 are added per month. 44 new ones are added to cities around the country every single month. And as I said, it is actually one of the fastest growing food movements. It's been actually picking up pace. It's been around for quite some time, but in the last few years, especially with the growth of organic and natural, and the sort of companies like Whole Foods and Wild Oats and other smaller chains, essentially proving the vitality or the viability of natural and organic foods, and the consumers' interest in that, farmers markets are popping up all over the country. One thing that's really kind of interesting is Walmart, not only the largest retailer in the world, but within the United States, depending on which numbers you look at, there's some companies debate this standing, but Walmart is the largest food provider in the United States. What's also interesting is that Walmart is the largest local food provider in the United States. The amount of local produce that moves through a Whole Foods market, or a Walmart, is more than any other retailer in the country. But what's fascinating is that the average food within a grocery store, not those local products, but the average food travels about 1,500 miles to get to a grocery store. What's actually shocking about the Walmart in particular, too, is that because of their vast distribution network, even if a product is grown, literally down the street from a store, hell, it could actually be grown on the roof of the store. It would probably have to go through their distribution network to get back to that store, and still have to travel some distance, even though they are the largest local food provider. That food still travels a significant distance, even if it's located right down the street. Recently, a new movement, sort of focusing even more narrow than just the term local, is, and being a little bit more specific, is something called the 100-mile challenge, and the 100-mile diet. I believe it was the Learning Channel or the Science Channel, I'm not sure which one, or it might even have been Planet Green, ran a TV show about a year and a half ago based on the book, The 100-Mile Diet, where they collected 13 families in British Columbia. I'm not exactly sure why British Columbia. That seems like a pretty harsh place to try to grow food year-round within a 100-mile radius. But they put 13 families, and they had to go, I believe it was 90 days, and eat only food that was within 100 miles. What was interesting is I stumbled on that show about halfway through halfway through the season, and was sort of shocked by how much complaining they were doing. So I started looking around myself and started thinking, well, I'm located in Los Angeles, actually just outside of Los Angeles in North Hollywood. What if I drew a ring of 100 miles and sourced only my food? Now, I have to admit that I'm pretty lucky in that I'm right at the edge of one of the most productive food areas in the world, which is the California Central Valley. So I can actually source quite a bit of my food within 100 miles. And that might be more difficult for lots of other people, but it started me thinking, once I did this, is there a way to think of building materials in the same way? So I started looking around at some of the materials, and most concrete, and concrete is one of the most popular building materials in the world, throughout the world. But most concrete, because of the fact that it has to be mixed, and because it hardens within a certain period of time, it can't be manufactured far away and shipped and still be pourable. So it has to be manufactured close to areas where it is needed. So the supply and the demand are definitely linked to one another. So you could sort of theoretically think of concrete in general as a very local material. But what if you break down the components within the concrete and start thinking about some of the more important pieces, like cement? Cement is the most vital piece of the components that make up concrete. Well, most cement is manufactured by taking limestone, mined all over the world, and in fact, very little of it in the United States anymore. Some of the largest producers of some of the largest limestone mines are outside the United States, but it's crushed, and then it's run through, the photograph on the right is actually the exterior of a kiln. It's a long linear kiln that rotates and essentially burns the limestone gravel at about 3,400 degrees Fahrenheit. This is a look at the inside of that kiln. It burns that limestone and turns it into cement. Now, China and India are actually the world's leading producers of cement. Most of the cement that's used in the United States comes from China. The United States, in terms of its rank of cement production, I believe is 4th or 5th on the list. There's quite a few countries ahead of us in terms of total production. Another material to think about is aluminum, right? Like here in Los Angeles, one of the most famous buildings built in the last decade is the Disney Concert Hall, and its twisting forms of and its skin of aluminum, quite a compelling piece of architecture, and really a beautiful piece of sculpture. But where exactly does that aluminum come from? If you trace aluminum, it travels quite a significant distance to get to the United States. There's a couple of key locations where its raw material, which is bauxite, is mined. There is no raw aluminum, unadulterated aluminum in the world, even though it's the 3rd most common material on the surface of the planet. it's not available in its raw form. It has to actually be produced through a pretty intense process. Starts off as bauxite. It's some of the largest mines of bauxite are in the center of Australia. Another big bauxite mines are also in China and also in South Africa. That bauxite is trained to the coast, where it is then processed into alumina, which is essentially aluminum oxide through a whole chemical process. They extract out the aluminum oxide. That aluminum oxide is then put on a ship and it's sent to China, where it is then run through a whole series of what essentially are, where it's electrified. With the photograph in the upper left-hand corner there is actually these bins. They're underground. You're only seeing the top piece of it, where electrodes are dropped into a bath of a chemical solution with the aluminum oxide, and it is electrified, and that separates the oxygen from the aluminum, and then they are able to actually suck out, actually vacuum out the raw melted aluminum. Now, there are production facilities in the United States, but the largest of them are in China. The vast majority of the aluminum, raw aluminum, is manufactured in China, where it's then turned into ingots or billets and then shipped to places like the United States, where it's then turned into other aluminum material. It travels thousands of miles before it ends up in any of our buildings or even in the can of soda that we drink. Bamboo has become quite a popular material in the sustainable materials world recently, just in the last decade. But all bamboo travels a significant distance. There are no domestic plantations of bamboo. All bamboo is grown in other parts of the world, where it is where it grows naturally, where it's indigenous. The areas of the map in orange in Southeast Asia, China, Vietnam, Indonesia, Malaysia, countries of Southeast Asia are where bamboo grows best. The interesting thing about bamboo is that it will start to degrade pretty quickly. So it actually has to be carbonized. Essentially, it has to be processed, kind of almost like a pickling process. But it's through a heat and pressure. Bamboo is converted into a material that then is much more sustainable in terms of the ability to travel long distances. So if they took just raw bamboo, stuck it in container ships and shipped it to the United States, it would be rotten by the time it got there. So most bamboo products aren't manufactured in the United States because they can't be. It's a function of the way in which bamboo actually operates as a material. It has to be manufactured in Southeast Asia and then shipped to the United States. So how do we start thinking about local materials if so many of the materials that even simple ones that I'm showing aren't manufactured in the United States, or their raw materials come from significant difference? Are there strategies to actually pursue that would help us think about sourcing materials locally? Today, what I'd like to suggest are 3 strategies for us to consider. First one is, how do we go about finding local producers? And there are a number of local producers in the United States. In general, most of them are small and independent. There aren't some of the largest manufacturers. There are some in the United States, but most of the sources that I'm going to show you are much smaller, more independent. Second strategy is seeking alternative sourcing. There are all sorts of interesting sources of materials that aren't necessarily sort of off-the-shelf architectural or interiors products or building products, but can be used as building materials. I'll talk about a few of those. And the third is, if it doesn't exist, create it. There's actually a very hungry manufacturing base in the United States looking for new things to make, and I'll show some examples of that. So let's start off with finding local producers. One online source to consider that's really pretty interesting is a site called Green Wizard. Now, what Green Wizard boasts is a database, I believe, of about 23,000 different sustainable products, or what they consider to be sustainable products. I'm not entirely certain what their criteria is for determining what is a sustainable or green product, but They do have a considerable database, maybe one of the largest in the world right now, and some of that can be searched by location. And so Green Wizard would be a great place to start in terms of taking a look at how to source some materials more locally. But again, what they will be identifying in their database is the location of the headquarters. So like I mentioned with the number 2 pencil, even though it's located, the manufacturing headquarters might be in the United States, it may not actually be manufactured in the United States. So something to consider. Another good one is Green Connect. They're actually in the process of rebuilding their database. It's still available online, but they're going to be introducing a sort of whole new version of their database, and they have the ability, in this you have the ability to look for various products, different projects, different companies and people. So it's actually, they're attempting to build a community around sustainability, which focuses on those 4 categories. So there are ways to actually go and talk to other people, and as you can see in the search criteria there, although this window is primarily for projects, the same sort of search criteria is available for products, so you can actually search by location. It's one of the better ones for location. Another one to consider is Eco Scorecard, although their database is fairly limited. The way this one actually works is a paid relationship between the manufacturer and the website. So right now they're still trying to build it, but would be an interesting place to also take a look for green products. Their searchability is a little bit more limited, and the ability to find local products is a little bit more limited, but still a resource to consider. Another one to think about is CSI has a program that they launched about 1.5 years ago called Green Format, and actually the images I'm showing here are from their iPhone application, which is quite nice. And it has a database of green materials which ties in with their master format, their material specification system. And so it allows you something quite easy to find a green material and plug it directly into your spec if you use the master spec program. There is some limited searchability regarding location. Most of it is product name or company based. Those are the most common ways to search this, but again, this is also an interesting resource to consider. There are a number of different showrooms that are starting to show up in different cities. The 2 that I'm showing, one on the left and one on the right. One is a West Coast base called Eco House. It started in Seattle. They also have locations in Portland and San Francisco, and I believe they have a 4th underway, but I'm not exactly sure where that one is, but essentially a Pacific Northwest-based company, but a showroom of sustainable materials, and with knowledgeable staff, they can certainly help in finding local materials. A really good resource to check out. On the right-hand side, on the East Coast, located in New York, is Green Depot, a little bit smaller than Eco House, and a little bit smaller in terms of total number of showrooms. Though they do have a lot of locations throughout the New York City area, they only have 2 showrooms, one in Brooklyn and one in Manhattan. But a very good place to go check out. Again, very knowledgeable staff, are very similar, and they actually focus exclusively on products within a 500-mile radius of the store. A product that I'd like to recommend everyone check out, especially if you're on the West Coast, is a company called Fire Clay Tile. Now, this satellite image that I'm showing here is of a quarry. It's a fairly large quarry south of San Jose, essentially between San Jose and Santa Cruz. And it's a rock quarry of one of the largest gravel manufacturers in the world. They make gravel, which then goes into their asphalt paving company, and this is one of their largest quarries. It's been operating for more than 80 years, as you can sort of tell by this photograph. It's really quite large. It's a pretty decent scar in the surface of the earth, but they have plenty of material to continue, so that they have no they don't anticipate the running out of rock anytime soon. But what they do have a lot of is dust that is a byproduct of the quarry. And where that dust comes into play is if we focus on this part of the image, this little building here, right along Quarry Road there. This tiny little building off to the side there, that's the main production facility for fire clay tile. Now the location is really interesting. This is crossing the tracks, driving to the fire clay tile facility, and this is where the actual rock crusher is for the gravel company, and where that dust I mentioned is produced. So for 85 years, this company's been pulling rock out of that quarry, crushing it into various sizes of gravel. And for 85 years, they've been having as a byproduct this fine powdery dust. It's almost like talcum powder. They have no idea what to do with it. They've tried all sorts of different things, trying to find ways to use it, put it into other products, use it as a filler, do all sorts of different things. To no avail. They haven't been able to do anything with it. So as a result, they've started just filling the hole back in with the dust that's left over. But across the street was a man named Paul Burns of Fire Clay Tile, and he is sort of this interesting mad scientist, and he decided there's got to be something he can do with that material. So here's a bin of it. You can see it's this sort of fine powdery material. He figured out a way after 2 years of testing to work it into his clay body for his clay tile. Now, the percentages vary depending on which tile they're manufacturing, which line of tile they're manufacturing. But generally speaking, it's about 60% of the tile body, of the clay body, is made up of that dust material. He actually adds in an additional 20% of crushed glass, which is also a byproduct of the glass recycling industry. As bottles are crushed and broken into smaller pieces, there too there's fine dust that's created of various different colors that can't be mixed in with the rest of the recycling, and it actually can't be recycled. So he's teamed up with a local glass recycler in the San Jose area and using their glass dust as a part of his tile also. Some of his other products include a collection program that he's done with San Francisco, San Jose, and Santa Cruz, and Oakland, where he's collecting old ceramic tubs and sinks and crushing those down and using that as raw material as well. But generally speaking, the line of tile that I want to point out is a line called the Debris series, which has as much as 80% recycled tile, all coming from local material, all coming from local sources. And there's about 120 different colors, different forms, different shapes. And actually, that's one of the most interesting things, is that it's not just sort of simple square tiles. Most of his tiles are really kind of interesting shapes, sort of brick proportions, and different sizes that are really quite nice. It's a beautiful line of tile. Another company to consider is one called Renewed Materials. They make a product called Alchemy. They're located in Baltimore. And here too, their sourcing came out of, or the sort of creation of the product came out of interesting circumstances, where the founder of the company, a man named Demir, wanted to figure out a way to use some scrap aluminum from a aluminum manufacturing facility in the Baltimore area. And he's developed a product called Alchemy, which is a solid surfacing material, most often used as counters, but it can be used for other surfaces as well. He's introduced a new line this year where the binder, or essentially the material that holds the aluminum, is made out of recycled acrylic. So when you combine the recycled, which is also locally sourced, and some of the coloration, so the photograph in the lower right-hand corner, that with a little bit of blue in there, some of that is recycled other solid surfacing. We don't know the exact source of that. That's a trade secret, but it is locally sourced, and it's recycled other solid surfacing material. He's also figured out a way to actually recycle his own material. So he's thinking about developing a take-back program where he can take his own material back, recycle it, put it right back into this countertop material, but all locally sourced, and all he supplies to the entire United States, or to the entire world, but is focusing largely on regionally providing. And right now he's currently looking at how to set up a West Coast production so he can source the West Coast and do the same sort of thing there. Another company that's really interesting out of Portland is called Eleak. They manufacture a number of different products, all made out of 100% recycled aluminum. They do a lot of light fixtures, which is the photographs in the upper right-hand corner. But they also make aluminum, 100% recycled aluminum tiles. They make switch plates, hardware, all sorts of different architectural components for both residential and commercial, and some really beautiful materials, all sourced locally. The majority of the recycled aluminum is sourced locally. Most of it comes from Northern California, so within a 500-mile radius. But they've also started a new program recently with a company in the Portland area called the Rebuilding Center, which takes donated building materials and reprocesses them, and often what they end up with is scrap pieces that can't be reused. And so they take those scrap aluminum pieces and they give them to Elec, which has figured out a way to melt them down, because aluminum comes in all sorts of different alloys, but they've actually figured out a way to mix them all together and create an alloy that is usable for their purposes, and developed an entire line of architectural hardware just out of the materials sourced locally from the Rebuilding Center. Really interesting products. Another one to consider is out of Texas, is a company called EnviroGlass, and they make a countertop and flooring material made essentially the same as terrazzo, but it's made out. Its aggregate is made out of locally sourced recycled glass. The photograph on the left is recycled. The white chips are from a Kohler manufacturer right up the road from the plant. They have rejects, a whole pile of rejects sitting in the back lot of the manufacturing facility. So EnviroGlass has teamed up with them to take pieces that have broken and turn it into aggregate for glass. So all of the components, with the exception of the binder, essentially the concrete binder in the mix, is all locally sourced. So let's take a look at the second one, seeking alternative sourcing. There's a number of online services that have come online recently. Two of my favorites is a company called Recycle Match, although their emphasis isn't strictly on architectural products. It's a mix of all sorts of different things. It's a really good place to go look for alternative materials. Planet Reuse, it focuses primarily on architecture, and it is a really good source to go look for local building materials that you can source for your projects. Both of them have ways of searching locally and ways to actually work with them to find local materials. Another is the Building Materials Resource Association. They actually have a pretty good website, and will work with designers and architects to find local building materials that have been salvaged or reused and are ready for reuse. And what they estimate is that what they consider rebuilding centers, and this photograph is actually of the one in Portland that teamed up with that company Elec, that it too is a rapidly growing source of building materials. There's 850 centers around the country of different sizes and different types, and counting. That list continues to grow. Another one to look at is Habitat for Humanity has their own Restore stores, which is all of the products in the store come from either donation or come from building programs with their Habitat for Humanity programs. And in fact, Habitat for Humanity is teaming up with the company I mentioned just a few slides back, Planet Reuse, to start a whole new website, which will then also have an iPhone, an iPad, and Android app for searching for local reused building materials, and it's going to be called Planet Restore. That will launch in February. Another thing to take a look at is salvage. Virtually every metropolitan area in the country has salvage yards. This is a map that was created for a project that I did a number of years ago in Richmond, Virginia, where myself and 5 other teammates all came in, members of the design team, plus other consultants, plus the client representatives. We all came into Richmond for a 2-day sort of tour of all the salvage yards in the area, and what we found was really quite amazing. There's a lot of interesting products. 2 photographs on the bottom there, the pressed aluminum panels and the radiators. Both of them were manufactured locally. Most of the salvage product was manufactured locally. Came out of local buildings, and we used both in a new store in the Richmond area for Whole Foods Market. Did some pretty interesting things. What's amazing about salvage is how sort of well established it is and continues to grow. Just looking at salvaged wood, this map here are just 22 different companies that my company has used around the country, or knows of around the country, or has relationships with around the country, who offer salvaged wood specific to local species, local coming from local salvage sites and things like that. There's a really amazing market out there of salvaged products. One of the largest is barn board. You know, the sort of transition of the farming industry from small local independent farmers to industrialized agriculture means that over the last 100 years, an awful lot of barns have gone vacant and unused, and are prime sources for wood products. One of the best that I've worked with is a company called Black's Farm Wood. They're located in the Oakland, or in the San Francisco Bay Area, but they also have a location in New York City, both attempting to focus on regionally sourcing materials, and they'll work with you to find materials in whatever part of the country you're located or the project is located. That's some pretty amazing product. There are a number of salvage sources that are looking at, sorry, this keeps coming up. Another one is urban logs, or urban timber, which is when trees fall during storms, or if they have to be cut down due to new construction or other things. There are companies who will go in and salvage that wood and harvest it. Some of the commercial people who are in companies who are embracing this, Anthropologie is working very hard to source a lot of wood material in their stores locally. Starbucks, although it's not really on the name of the stores, they've attempted a whole new line of local stores. They actually call it glocalization. So they're doing a global look at how to localize stores. The first one of them was the 15th Avenue Coffee. These photographs are of it. It was a totally unbranded store. It barely said Starbucks anywhere on it. It did have some Starbucks product inside, but their attempt was to really focus on location. In this particular case, this store was located on 15th Avenue in Seattle. They also tried to figure out how to use local materials. They tapped into local sources of materials, local salvage materials, local artisans, local producers, really attempting to make the stores as local as possible, use old equipment of their own, so even old pieces from their distribution centers or from roasting centers. So that's the measuring bin on the right hand side, actually came out of one of their distribution centers. REI has had a history over the last decade of using local sourcing of materials and trying to figure out ways to use things that are on existing sites. So in the photograph on the right-hand side, the big boulders in front of the fireplace, and actually that make up the fireplace, were all taken from the site itself. Another one is a small little company out of Santa Cruz called New Leaf Community Markets. Has a very heavy surf and sailing culture, so they tried to figure out how to source local materials that would also be relevant to the community that they're serving. This was actually a client that I worked with, and we figured out a way to take sailcloth and then turn it into manufactured into light fixtures. We actually manufactured them in the Los Angeles area, in the garment district. We found a local company to manufacture the light fixtures and all of the hardware, and then take it to Santa Cruz, all within 500-mile radius. The third one I want to consider is, if it doesn't exist, how can we create it? So an interesting company that I found recently is Ecor Advanced Composites. So one of the things they're taking a look at is how to take old cardboard, essentially cardboard that has reached the end of its life. It's been recycled enough times that it can't be recycled again. And they're teaming it up with what they call processed bovine fiber, which to the rest of us is actually poop. They take bovine, it's essentially cow manure. They run it through an anaerobic digester. One of the byproducts of the digestion process, a 28-day-long process, is methane, which is used to actually electrify or generate electricity to run the anaerobic digester itself. And then a second byproduct is pure fiber, which can then go into the manufacture of a product. And it's this company who's doing this is called Ecor. They're out of San Diego. Some of the materials that they're manufacturing is a building product called Ecor Flat and Ecor Grid. And so it's you can take a flat sheet and a corrugated sheet, and you can glue them together in all sorts of different ways, and create some really interesting things. This is a look at one of their presses to manufacture that. They're teaming up with Whole Foods to make all sorts of really interesting components within their stores. So a lot of their signage is made out of the material, super lightweight. All sorts of elements, overhead elements, especially in Southern California, where seismic is a real issue, and they're manufacturing all sorts of different signage and overhead components. One of the interesting things about Ecor is that you can throw in any kind of packaging material at the last minute in the press, and it actually fuses it into the surface. It's not an extra layer; it's actually a part of the fused surface. Really kind of beautiful things here. You can see it, even some of the text is quite legible. So I'm working with them to actually team up to take corrugated baled cardboard from existing stores in Southern California area and turn it into new material, new building material, which then goes into store programs as a part of a remodel retrofit program. We're just starting it. It's a pilot program, but essentially what we're attempting to do is tie two things together. I've got a client who has waste material from existing stores that they're paying somebody to haul off as a part of a recycling program, but that material can then be used if we divert it and take it to Ecor, manufactured into new panels, which and then go right back into the stores, essentially close things the loop. Another thing that we're doing is talking with the San Diego Zoo and trying to team up San Diego Zoo and Ecor. San Diego Zoo actually, surprisingly, does not have a comprehensive program for processing their animal waste. There's a number of animals, rhinos, giraffes, and elephants, who have inefficient digestion systems and can actually produce essentially a manure that can be run through the anaerobic digester process and produce very high quality fiber. And so we're looking at how that can then be brought back into the San Diego Zoo as a part of their exhibits. So a lot of what we're doing with some of our clients, and I recommend this with anyone, is taking a look at what's in their own dumpsters, in their own construction dumpsters. If they're a commercial company, or even if they're an office building, they have some sort of waste that has fiber material that it can be manufactured into other things. We're currently talking with the U.S. Forest Service, which is a part of the U.S. Department of Agriculture. They have a forest products lab in Madison, Wisconsin, which is actually where the technology for the Ecor was originally developed. They're working on all sorts of different product developments. They don't commercialize any of the products, but they do research to try to figure out new product ideas. And we've started talking with them about developing some new products, and they're very interested in doing anything that's a composite panel made out of some amount of fiber. So one of the second tests we're going to do with Whole Foods Market is to figure out how we can take their food waste from their grocery stores, essentially the produce and waste from the produce area, things like shrink and damaged goods and things like that often end up in the dumpster, take that, divert it, and turn it into panels as well. There's a number of different companies, one also in San Diego, or in the San Diego area, called Keyray. And the founder of that company, John Stein, is doing some really interesting things, searching out ways to take all sorts of different waste agricultural material or waste manufacturing material. This photograph is of a panel that he's doing some tests with, which is waste material from furniture manufacturing I believe it's in North Carolina, and trying to figure out ways to manufacture products which then can be used in the mid-Atlantic states. Out of this material. He's also testing ways of doing things with hemp. Obviously, that's a problem here in the United States. Hopefully, someday in the future, we'll actually be able to grow and use hemp. It's an amazing material, especially for all sorts of different types of construction materials. So what I hope you'll see in all of this is that there are options for looking at local materials. This photograph here of Frank Lloyd Wright's West Coast Operation Taliesin West was very famous. He was very famous for using local materials, but that idea really isn't new. That was actually something that was done for thousands of years. It wasn't really until the industrialization of building materials, or the globalization of industry that meant that products could be manufactured virtually anywhere and shipped easily to just about any location. All of that reliant on petroleum. Nothing can be shipped or processed in virtually any way without the existence of petroleum, which sort of created a whole globalized industry, the ability to sort of ship things just about anywhere. And what happens is that we're always chasing the next sort of labor pool. We're always industry is always looking for the next place, and maybe eventually it will come back right back to the United States. That's sort of my hope, is that so much of our manufacturing has left, but now there's a whole new sort of wave of small manufacturing that's taking place in the United States, and hopefully the next labor pool is actually right here in the U.S. What's happened as a part of this in this sort of globalization is that there's a Home Depot is Wisconsin's home improvement warehouse. And we probably all have Home Depots everywhere in the country. The problem is they all look essentially the same. Pennsylvania's home improvement warehouse. This is also Ohio's. All look essentially the same. There's this sort of homogenization which has occurred, which totally destroys any sort of connection to local or to the community. What we're also doing in sort of ignoring our local sourcing and our own communities is that we're creating manufactured landscapes that are really quite ugly and really quite dangerous to us. These photographs by Edward Brzezinski, really quite amazing photographs from all over the world of really amazingly strange manufactured landscapes. And we're causing the impact. We're causing a sort of a scarring and impact on the planet that is something really to take a look at, and that localization can help to solve. And what I hope you'll understand is that really the time to act is now. What we really need to do is move now in order to make a change in this. And with that, I'll close and hope that everyone feels compelled to move forward and try to find local sourcing of materials. Thank you very much.
Thank you, Kevin, very much for that wonderful presentation. Very glad to have you with us today, and we hope everyone really enjoyed it. I know the chat box was really going and very active during the presentation, so we really like that. I'd like to remind everyone again that we have the ability to answer your questions now at this time. If you have any questions, please use the chat box there, and we'll be able to go through them and ask a few of Kevin here. I know we're getting close to 10 o'clock. All right, Kevin, well, I'll just start if you're ready.
Sure.
Okay. Well, when you were kind of going off on the different rating systems and different, excuse me, I forgot we have a poll. Just a quick poll for everyone that's currently still watching. Are you currently working on a green project? We have a couple different options here. We have planning on it. You're planning on going forward with the project. If you have a project that's currently in process, if you just completed a project of your own, and also if you have no interest at this time in going ahead with the green project. So we're definitely interested in seeing your thoughts on that. And as soon as you vote, you'll be able to see the responses as well, and kind of the differentiation there. It seems like planning on it is getting the majority of the responses. 16 responses out of about 40, I believe, close to 40. So almost half, actually. And then actually projects in progress are catching up as well. And actually now we're taking planning on. I don't know if you have any thoughts on that, Kevin. If you've seen kind of a rise in sustainable projects, especially using local materials, and if let's say work is ramping up for you, and like.
Yeah, I've seen a rise in it, but I have to say that might be a little biased in that it's also what I'm seeking out. So it's easy to see what you're searching for, or easy to see what you sort of want to see in that. But what I am seeing is, because most of my clients are commercial and retail, that there is a growing interest there. I mentioned in the presentation a couple of programs that I'm working with Whole Foods, one of my clients, which goes beyond architecture, right, in trying to figure out how to take their own waste and turn it into building product, which then goes back into their stores, is tangentially connected to architecture, but it's really an operational issue because I'm getting involved in all sorts of meetings with operational people and all sorts of other logistics that really don't have much to do with, and that encourages. That's one of my architectural clients wants to do more than just build a building. They want to do things that solve other problems. And I'm seeing more and more of that. I'm seeing more interest within the markets that I've been serving to sort of pursue alternative strategies like that.
Great. We also have another question here. I'm just going to keep going in the interest of time. We have a question in going over those materials and those resources online, particularly. Do you have any suggestions for someone that's looking for a resource like a website that identifies regional products with reduced impacts?
Well, the websites that I mentioned, there's the problem with all of them is that none of them are focusing exclusively on location, maybe with the exception of the upcoming Planet Restore, which is the teaming of Habitat for Humanity and Planet Reuse, the website, in trying to figure out ways of doing things that are very local. Most of the other sources of, let's just say, databases that are out there online are very, in order to appeal to the broadest audience, they're very broad in their scope, and as a result, location is maybe one of the attributes that they're tracking, but isn't exclusive. So there is some searchability. You can sort of essentially rig the search and kind of get the information that you want, but there really aren't any great sources out there right now. There's one that's currently building that I can tell you about. It hasn't totally launched yet. It's a company called Sustainability Matters out of San Diego, and they're attempting to do something very similar to what I'm mentioning, and focusing on local or regional source products and the ability to categorize them and search them that way. But most are not seeing location as a sort of high priority, and so it is a searchable attribute, but not a key one.
Okay, well, I think that as these projects are coming more into fruition and people are getting more interested in local materials, it'll be more important for these sites to go onto that.
Absolutely. I think as interest grows, I mean, if the architectural community, the interiors and construction, if all of those industries start pressing for that, start insisting on getting knowledge about locally sourced materials, then the manufacturers and websites and services will all start catering to that or start addressing that. So it's sort of a slow build right now.
Okay, I'm going to go and give you one more question here.
Sure.
Since people are still kind of concerned with the resources and website aspects of it, is there one in particular that you like to use or you recommend to your clients in their projects that kind of have like cutting edge materials and kind of the newest and latest and greatest with regards to materials?
Well, one of the best sites generally for searching for materials is Green Wizard. It requires a membership, but it's very small. It's like I think it's like $20 a year. And like I said, it's one of the largest databases of green or sustainable materials available at about 23,000 different products. It's one of the largest. So in just terms of a comprehensive, searchable list of products, it's probably one of the best. One of the ones that is not as good as it's going to be is greenconnect.com. And I mentioned them and said that they're in the process of rebuilding their database, sort of rebuilding the whole back end and how it's going to function. And I actually know the founders of the company, so I've seen some of what they're going to be doing. It's supposed to be launching in the new version is supposed to be launching in 2011, and it really should be pretty amazing. So I would recommend keep going back to that, because they're going to do a whole sort of integration with Master Spec and some other things to try to sort of figure out ways to make it even easier to sort of find materials and plug them right into your project. One thing I failed to mention about greenwizard.com is that they teamed up with the USGBC recently. They just announced at the latest Green Build a partnership between the two of them, and a way for anyone who is doing LEED projects to actually use their service to directly fill out forms for LEED points and LEED contribution of various products, which is a pretty significant thing for anyone who's looking for LEED certified, looking to work on LEED certified projects. On the reuse side, planetreuse.com, which is one of the ones, I think it's .com, but just type in Planet Reuse in your search. I can't remember whether it's a .com or .org. That one's a great one for just unusual reused building materials. You can find all sorts of different things there. It's really, really quite amazing. So those are three that I would highly recommend.
Great. Well, in the interest of time, we're actually going to end it after this last question. I do apologize. I know we have some other great questions from the audience. We're definitely going to get you those answers after the webcast today. We're also going to be able to provide a way for you to access the presentation and the slides as well. So I do thank you all very much for joining us. And Kevin, I definitely thank you for giving a great presentation today.
You're welcome.
I'm going to announce the winners of the book. As I mentioned earlier, Drew Meadows and Ross Spiegel recently released a 3rd edition of their Green Building Materials book. And the winners from today's presentation and the attendees are John Neville, Sherry Gruder, Bernie Jess, Lisa Feldman, and Teresa Young. And we're going to follow up with you after the show on in terms of the details and when you should expect to receive the book. As has been mentioned in the chat, Green Building Pro has a number of case studies and information for you to access. You're already on the site, which is great, so you can navigate to the articles, white papers, or case studies and gain a lot more information. Also, do check out our resource directory, and we hope to see you at our next online broadcast.